We have a buddy Samson. He wants to buy a new car for a certain amount of money. The value of the car decreases by a certain amount every year, by a certain percentage, and we want to know when the car has a value of $8,000. So in this problem, I'm not seeing the word compounded anywhere. So this is out and this is out. Not to mention the value of the car decreases. This is the only equation we have that accounts for decreasing. We'll use the version that has just the minus sign in it. So I'm going to use the formula, the amount equals the initial amount, 1 minus that rate of decrease to the t power. I need to fill in a value for A, for P, for R, and the question is, when will the car have a certain value? So T is going to be my unknown. But P is the beginning amount. He bought the car for this much money. That's the beginning amount. So that's my value for P. The car decreases by this percentage every single year. So that as a decimal, take this decimal spot always 2 places to the left when converting a decimal to a percent to a decimal. So 0.085 is my rate, and we want to know when the future amount will be $8,000. So this value for A is 8,000. And we'll take these different variables with the t being unknown into this equation. So $8,000 is going to equal $17,325. 100% of the value minus 8.5% of the value every year for how many years? That's what we're trying to figure out. Now as we go through and try and solve this, in this form it's pretty gross looking, so what we want to really do is just take a minute to pause and simplify. This is a calculation I could definitely figure out, 1 minus 0.085. I'll use my calculator for that. 1 minus 0.085. So we have a 0.915. So leave this guy alone. Leave this guy alone. And then this, oh, I just forgot the number. 0.915 to the t power. I'm going to want to get that t out of the exponent, so I'll have to switch to log form. But before I can do that, this whole part of things has to be isolated. So this 17,325, it's got to go. We have to get rid of it first. Since it's multiplying, I'm going to divide both sides by 1,703, whatever, the number that I'm writing down, 17,325. This again looks like a job from my calculator. $8,000 divided by 1,7,325. Don't round. Just leave. I'm going to write down a rounded number, but I'm going to leave this on my screen. So I'm going to write down 0.462. But I'm going to leave that whole entire number on my screen. And now I got to switch to log form. And my question is, what's the base and where's the exponent go? So the base is 0.915. Log of base 0.915 equals t. And the 0.462 goes here. And now I do have to use a change of base formula. So it'll be the log of this, the answer that I just had, divided by the log of 0.915. So the final answer is t equals 8.699 years. We'll leave it like that, 8.699 years. And if you didn't like the answer, if you wanted to check your work, you could always take this value, 8.699, up into here, actually up into this version of it. I can take this 17,325 I started with, to the 0.915 to the 8.699 years, and the answer should be about 8,000. Yay. So it's the same stuff. The numbers are gross. You got to use your calculator more. Maybe check your work to build up your confidence, but you can totally do this. Good luck.